Lighter-than-air craft. To us, they are known as blimps and are used for advertising, broadcasting live events, or short pleasure rides. But back in the 1920s and 30s, these were considered the transportation wave of the future for traveling across the Atlantic and around the world. I'm weather-bug meteorologist Rachel Peterson. Let's focus on one specific lighter-than-air craft, the Hindenburg. You may have heard of it. It was made by the Zeppelin Company in Germany, and on May 6, 1937, it crashed over Lakehurst, New Jersey. 35 of the 97 people on board died. There are many theories on what caused the crash. One suggests sabotage, another engine failure, and two others suggest the weather caused the explosion. In order to understand how the weather could play a role in this disaster, we need a little bit more information about the craft. The Hindenburg was made of a metal frame. The frame was skinned with cloth. Inside were 16 bags filled with hydrogen. Hydrogen is extremely flammable and lighter than air, giving it lift like a balloon filled with helium. When the airship goes to land, it drops mooring lines, much like a ship when it docks. In fact, the Empire State Building's distinct Art Deco spire was originally designed to be a mooring mast and depot. The 102nd floor was originally a landing platform with a gangplank. If the craft was docking on the ground, it would release hydrogen gas from the bags through the vents in the top of the ship, making it drop. Since hydrogen is flammable, it wasn't to be released during a thunderstorm. This is to prevent static electricity from igniting the gas and starting a fire. On that fateful day, stormy weather in New Jersey prevented the Hindenburg from landing. It took the scenic tour over New York City and circled around for more than an hour, waiting to land when the weather was clear. Some speculate that flying through the thunderstorms caused the skin to become negatively charged, and the wet mooring lines attached to the metal frame to act as conductors of electricity when they were dropped to the ground. The electrical charge traveling from the ground to the ship ignited the hydrogen, causing the craft to burst into flames. This theory is the most known. However, there are some who suggest a single lightning strike could have sparked the fire. In 1937, there wasn't sophisticated lightning detection technology like WeatherBug's Total Lightning Network, so it was harder to figure out if lightning was or wasn't involved. No matter what the cause, it only took 32 seconds for that mighty airship the size of the Titanic to crash to the ground engulfed in flame. And that was the end of the lighter-than-aircraft flying era.